STEM education considered a topic that is currently on the cutting edge, that is requiring interdisciplinary integration connection of several subjects, and that is really considered as a shift of the discrete subject model that we have in schools these days into an interdisciplinary integrated model that requires the blending of different concepts to develop meaningful understanding for students. And this is really goes back to the shift of the reform agendas where they call to change, look at integration as a mean for developing education worldwide. And that is really coming from different reasons. One of it will be like natural, human cross boundaries. Actually, in daily life, we usually integrate things in our daily life. In addition to that is like naturally part of our thinking. When we think collectively, and we bring about different perspectives, knowledge, and so forth into one meaning. And also for some other needs, we call it political, sort of like, need for space or time and so on. The STEM stands for science, technology, engineering, and mathematics. And this is really an acronym that is originated in the US in the 1980s. The integration itself is like really rooted back 2 years. However, STEM really was like a need that originated from the engineering colleges in the US, where they felt that there is a need to have knowledge for students to have a background, multiple background of sciences, mathematics, and technology. It wasn't easy just only to teach them engineering. And from that time, they start to look for which departments that can really help to boost that kind of need. And I think it went to the education, and in particular on science education. So science education is the father of this area, and it is really a blooming area where we can really see some of its models, in addition to the prospect of its career development and other issues related to AI and so on. So if we talk about the models, usually it has like 4 models. 2 of them are true integration, and 2 are not. So, and what determines those levels, or actually these different types, the level of integration itself and also the shared knowledge. And what we mean by that is that what kind of information that is required to be included and how many subjects, that will determine one leg. And the other leg is that who is sharing that knowledge and who is really benefiting from the knowledge. And if I go with the first one, we call it the disciplinary. And the disciplinary model is that what we are doing right now in most of schools all over the world, which is one particular subject that is taught and learned, and then the is being assessed and so on. For example, it's just like a science itself or by itself, and mathematics and social studies and so on. However, and that's what you call it disciplinary. Some researchers are calling it fusion. The second type is really the multidisciplinary, and in that one actually there is a concept or concept that are really looked at, but in terms of like adding. So you add a concept from mathematics and another concept from engineering, for example, or technology, and you deliver that. And they call that this not a true integration. It's just an add up. So additive kind of type and not integrative. The last 2, these are true integrative actually types, which is the interdisciplinary, and the last one is a transdisciplinary. The interdisciplinary, you really have different concepts across for a particular problem. So it all has to be around one problem that it really requires like some solution and to bring about some meanings, and that's the interdisciplinary approach. Again, it is a lower end of integration. However, the last one is a thematic integration, where the concepts are only used to develop the meaning for the theme. And the theme, definitely it has like multiple problems and not only one problem. And then the outcome is really to have that common understanding of the themes, and wherever the concepts are coming from across different disciplines, to make that meaningful understanding. That's what we aim at, and that's what we look for. So the transdisciplinary is really the best. It requires a lot of work in terms of the planning, in terms of the setup, in terms of like different resources, and also the skill for the students to develop such like environment of learning. Why? Because it will require like collaboration, sharing of ideas, appointing some like individual to do certain things. It requires the work of team. So what we call these actually the 21st century skills. And those are really, some of it will be like the problem solving, collaboration, and critical thinking. So via this kind of environment and work, you will find that the students are becoming more active, and they will develop meaningful for themselves, and they will really be useful in terms of application. So it will lead to those needed goals we usually look for in education, to really go all the way from understanding what is being given all the way to how is being used and applied in life, and also it becomes part of the behavior of the students. If we talk about the career opportunities, many actually career opportunities coming from STEM related fields. I looked at the top 10 jobs actually coming out from a survey in the US. 7 of them are related, or actually 5, 6 of them are related to computer, and that is giving us actually and they are all STEM related. So the technology is really bringing to us like a challenge, and that challenge is really how to use the technology wisely in a way that to develop these fields. Technology by itself won't be enough. We need to really utilize it in a sense that we will bring about like a bigger picture of understanding and developing like good career path. So some of these like jobs are really computer programmers, web developers, analyst, statistician, looking at architect, analyst as well. And that's what we'll show you how this is really relates to computer and analysis. And also it requires the mathematics and science and technology, and also the engineering aspects. So in a nutshell, actually, STEM, it will push all the countries to look at developing policies and strategies to accommodate this different shift of education. Is no longer compartmentalized. It is really integrative, and looking at what is important for students to develop the meaningful understanding, rather than the quantity of knowledge that is really most of the time is being lecture to the students without full understanding. And in that case, we will have like less of knowledge and more of skills and understanding. This is really goes along with all the reform agendas, where they call for this kind of movement, where we can really start to look for true integration of all our subjects. And also this goes from K to 16. So it goes from like general education into university, college, and level. This is really give us the idea for why this approach, or actually the STEM education, really develop this neat idea or neat field. Actually, it's a new field, and this is really going away from the traditional sense that we already have. In terms of like research, we have been doing like many like topics related to STEM education, and that to try to understand, how we can advance this approach. Is definitely research is important, and for that reason we will find that some of our research and some of our students are really developing different ideas in terms of looking at investigation of STEM at elementary level, middle level, high school level, looking at higher education, looking also at a thematic analysis in terms of really looking at factors that affect such approach, and see whether that is really is being implemented or not, what kind of challenges that are there. These are also areas. Looking at the formal and informal STEM education, and of course we will find some of the STEM that is done beyond the schools and beyond the classrooms, and that is also good and can be captured in terms of research. The research went all the way to talk about entrepreneurship, looking at the business aspect of STEM, and that is really give us the idea that STEM is no longer just only the 4 disciplines coming together. Actually, wherever you feel that really makes an advantage for this field, we find that we have included or accommodated that, such as arts. So, and that what we call it STEAM, actually not STEM, with the A, adding the A, which is the art, stands for the arts. Some people talk about the creativity and the artistic part, and some people talk about the the language acquisition and the language arts in terms of the social studies and so on. So that's one stop into those only 4 or 5 areas. Also, we have the reading that is being included in particular, and that's the stream. So we have STEM and STEAM and STREAM. These are all different acronyms, and they are really leading to different approaches for giving students more opportunities for being more active, independently learning, and also develop their own understanding and apply it to life. And so this is really part of what we can provide in terms of this STEM education. We have it in the British University in Dubai. We have programs that are really related to this, and that will include really in particular doctoral programs, and that will help us to really just develop those research ideas and move forward with the agenda of the UAE, and also develop the research globally. Thank you.